A little bit about the kinds of types that exist in Java. There are two basic kinds of types in Java, two big classifications. And really what we're going to be concerned about right now is primitive types. But if something is not a primitive type, it is basically a class or an object. And we'll get into classes and objects later. But basically, a primitive type is going to be any kind of type in Java that is not an object, that basically is what it says. So what I mean by that is that a primitive type, if you assign it to something, that value in memory is exactly what you assigned. Whereas objects and classes, other types that are not primitive types, what a variable really represents in Java is a memory location. It's a reference to a memory location. And this is kind of confusing, especially if you haven't done very much programming. You don't really have to understand this concept. I think a lot of people teach this concept very early and confuses a lot of people, but you don't really have to understand exactly how this is happening in memory. But just to know that a primitive type is a special type that has its value exactly represented, and it's not a reference to something else. And as we get more in depth into more advanced Java topics, that will make a lot more sense. But really all you need to know right now is that a primitive type is a special type in Java. And these are basic types. These are the most base types. Primitive types are not types that you create in Java. They're types that exist in the language. So if we look down this list of primitive types in Java, there's things like a byte, and a byte basically stores memory data. It can store a value from negative 128 to positive 127. It's basically a computer byte, if you're familiar with that term. If not, it's okay. The next one is a short, and a short is basically a 16-bit number. And what that means is that that number can store 16 bits of information. So this would be negative 2 to the 15th power, or positive 2 to the 15th power minus 1. Well, basically, the value is negative 32,768 to 32,767. That's how much can be stored in that data. It's really the size of the variable of what it can store. An integer is the same thing, except it's 32 bits, so it's much larger. We're not going to go over all the numbers on each one of these, but it's twice the bit size, which means that it can store an exponentially larger number. A long, you could probably guess, is double the integer. It's going to be a 64-bit number, which is a huge number. But it's a number from negative to positive. It can hold either a negative or positive value. All of these, short, int, long. A float, a 32-bit decimal number. A double is twice that. It's a 64-bit decimal number. A boolean is true or false. It's 1-bit value. And a character is a 16-bit character, a character that you would find in the keyboard. It's basically a letter or number. And then finally, the last type that it's not really a primitive type, but it's treated like a primitive type in Java is a string. A string is actually an object, and a string is a sequence of characters. Like when we create our Hello World program, and we said Hello World, that, what was in quotes there, was a string. So a string is really an array of characters. It's a chain of characters, but Java makes it real easy for you to work with this type because it treats it like a primitive type for all intents and purposes. And we'll cover string as a special case a little bit more later. But this is the basic idea, that these are the primitive types that you have in Java. And if you're using one of these types, the difference is, and we'll get into this a little bit more, is that it is going to have that type directly stored in memory. So when you copy the value, it copies the exact value. Whereas any type that's not a primitive type, it's really the variable is referring to some other memory location, and the value that you'd actually find in that variable is a reference to that. Wonder, why did we even introduce primitive types if we don't really need to understand what the difference is so much, and we don't really care about references in memory? Well, it's because I wanted to introduce this important concept in Java to you, which is boxing and unboxing. And you kind of have to understand what a primitive type is in order to understand this idea. And this is an idea that I think a lot of advanced Java programmers might not even know about. It's an idea that really kind of can make people a little bit scared because it seems complicated, but it's really not complicated. Here's the basic idea. We said that we have these primitive types, like an integer or a boolean. Well, each primitive type has a corresponding object. It has a type that is a non-primitive type that is the same thing. So the lowercase int has an integer class. The lowercase boolean has a boolean class. And we talked a little bit about classes. We'll talk about that more later. But basically, it has a non-primitive corresponding type for it. And those types act as a wrapper. So what do I mean by a wrapper? Well, if you look at this diagram here, you can see that I've got an integer. It has a value of 3. And here I've got the big integer, as it's called in Java, or the non-primitive type integer, and it stores the primitive type integer within it. And so it's acting as a wrapper. And so this can be passed around. And the only purpose of this is that there are certain methods, there are certain things that you need to do in Java that have to take a non-primitive type as an input. And if we did not have this ability to have these wrappers, then we wouldn't be able to call these methods. We wouldn't be able to use this functionality in Java. And so that all that we're doing here is, it's called boxing and unboxing because you can imagine this as a box. We're taking our primitive type, we're putting it in a box, and we're sending that box over to whatever method or whatever thing that we're going to call that requires a non-primitive type. And then when it gets it, it might do whatever it's going to do with it and return us some value that's also in a box. And then we take our value out of the box, and now we have the primitive type that we can use again. And a good way to visualize this is, let's say that you wanted to ship some baseballs to someone on the other side of the country. Well, you couldn't just go to the post office, take 5 baseballs, and say, ship this. You need to put it into a box first, because the post office doesn't operate with round objects. They don't really ship baseballs individually, right? You would have to box it up, take the baseball, put it in a box, and then you can ship it. And then let's say that someone shipped you one in return. Well, they wouldn't ship you just a loose ball. They would ship it to you in a box, and then you'd pull it out. And so this is the same concept here. It's just the certain methods or certain things in Java require a non-primitive type. And because of that, the primitive type needs to go into a box so that it can be given to that method. And then you can take it out of the box when you need that value back out. Now, Java will do this automatically for you. As we'll see when we actually get into some method calls, when we pass a value through a variable, Java can automatically take an integer, and it knows that if this method requires a non-primitive version of the integer, it can automatically auto-box. It'll put that integer in a box and then use it. And the same thing will happen if you try to assign a value out that is in a big integer, in the box integer. And your variable is of the non-box type, the primitive type integer, it's going to unbox that automatically, so you don't have to do this, you don't have to do anything. The reason why this is important is you need to understand this is going on because it can be a costly operation to do boxing and unboxing, especially if you're doing this in your code where you have some kind of loop and you're doing a lot of operations that are requiring a lot of boxing and unboxing. And kind of where this happens is more of an advanced topic, but I just want to introduce this concept to you so you know what's going on when someone's talking about boxing and unboxing. So let's take a look at some of the operators that exist in Java. And an operator basically is just something that goes in between two variables or two things inside of a Java statement. And a good way to think about this is we already do this in arithmetic, in any kind of math. We already have operators that we use to add numbers together. It's the same concept here. In Java, in fact, we have math operators. And I'm going to go down this list. I haven't included all the operators here. I've just included a lot of the basic ones. So this is not all the operators that exist, but it's the ones that are the most basic. For someone learning Java, you're not going to need to know every single thing. I'm trying to reduce this set down. So the math operators, you can see here, these are basic ones that you're probably already familiar with. Subtraction. If you use a subtraction operator, you can say 3 minus 2, and then the response that's going to come out is going to be 1. Same thing with plus. You have a multiplication. If we go down the line here, you'll see there's 2 division operators. One of them is a whole number division, and the other one is called modular or modulus. And what this does is if you take, for example, 5 and you use the regular division sign, the slash, divided by 2, the result is going to be 2 because it's only going to give you whole numbers. It's so that you're not having something that was a whole number type and converting it to a decimal. That is if you're working with whole numbers. If you're working with a decimal type and you do the regular division, it's going to give you a decimal number. But if you're working with integers or whole numbers, it's only going to give you a whole number back. And that's why that second modulus operand exists. That operator, it looks like a percent sign. If you said 5 mod 2 or 5 divide 2 using that operator, it's going to give you back the remainder, which is going to be 1. So a little bit confusing if you're not familiar with the concept, but it's basically the 1 gives you back the whole numbers that go in, and then the second one, the modular one, gives you back whatever the remainder would be if you're doing long division and you got a remainder. That's the value. Next down the line, you see this weird plus plus and minus minus. All this does, these are called increment and decrement operators, and if you put this at the end of a variable or a statement, it will make it so that that variable gets incremented. So if you had a variable x that was equal to 1, and then you did a plus plus, it's now going to be equal to 2. And if you did minus minus, it would be equal to 0. So it's just basically a shorthand way of incrementing or assigning that variable, whatever it was, plus another, or whatever it was, minus another. And there's a version of this where you can do this before or after a variable. And we're not getting into the specifics of that right now, but just to know that you have that ability. So the next set of operators is assignment operators. And we already seen some of this in usage. We already use an assignment operator to assign a value. When we said int x equals 3, we use this equal operator, and that allowed us to assign a value to a variable. This is how we give a variable a value. And then you have all these weird looking assignment operators. You have a plus equal, a minus equal, a multiplication equal. All this does is this is another shorthand, and this is a shorthand for saying take my value and then assign it to whatever I put on the right hand side of this operator, plus whatever it was, or minus whatever it was, or multiplied by whatever it is. And so this is just a shorthand. We can write out the plus operator, for example, the plus equal. If we said x plus equal 3, it's going to be whatever its value was plus 3, so we could rewrite that as x equals x plus 3. It's just a shorthand, but we have all these operators for each one of the corresponding math operators. Next is relational operators, and these operators are going to compare two things. And as we get into conditional statements, then this is going to make more sense. But for now, we're just going to overview what these operators are. What it basically lets you do is to evaluate whether two different numbers or variables or types and see is one greater or less than the other, are they equal, are they not equal. And this is going to be important when you want to choose something, when you want to say, if this number is greater than the other one, then I want to do this. Or if this number is less than the other one, then let's stop this loop. So you can see that these probably already make sense here, a lot of these. You have a greater than symbol, a less than symbol, greater than or equal to. This is true if it's greater than or equal to, a less than or equal to, and then this equal equal. This is a true equal, and the reason why this exists in Java is so that assignment doesn't get confused. So when you see an equal equal, it's actually asking the question, are these two equal, rather than saying, I want to assign this value. And then the last one is not equal, and this is asking whether or not these two values are not equal. It's true if it's not equal. It's the opposite of the equal equal. Finally, we have logical operators, and once again, this we'll go through a little bit of an example of this, but you have your and, an or, and a not. And the first one, the two ampersands, is an and it works just like logic. If you're taking a logic class, or you're familiar with logic statements, truth tables, it's the exact same concept here. If you have a variable that's equal to true, and you apply an and to it, or an and to a variable that is also equal to true, the result is true. If you had a variable that was equal to true, and you say and another variable that was equal to false, it's going to be equal to false, because they both everything has to be true for an and statement. The or, either one can be true. So if you had a variable that's equal to true, put the or in between, and you had another variable that's equal to false, the result is going to be true. The only way an or is not going to be true is if both sides are false. And then the not just reverses whatever the value is of a variable. If you had a variable that was equal to true and you put a not in front of it, it would now be equal to false. If you had a variable that was equal to false and you put a not in front of it, it would be equal to true. And these apply only to Boolean types of variables, which a Boolean type is one that can be either. So now let's take a look at some of the operators that we had covered in the slides. Well, let's look at some simple cases first. We'll create a number and set its value to 3. And you can see here that we have actually used an assignment operator. This equal assigns the number. We've already seen some usages of the math operator. We can assign our number to 3 plus 2, which would be 5. We could assign our number to 5 minus 1. We can do multiplication, division. So the basic math operators. We can also take our number and do plus plus, which would increase that number. So if we were to look at what that would do here, I'll go ahead and print out what our number is after we've done the plus plus. You should see that it is now 4. So that's all that the increment operator does, and we could also have used the decrement operator as well. We've already seen the assignment operator, but let's take a look at how one of the more complicated assignment operators works. So for example, we can do number plus equal 2. And what this is going to do is it's going to be the same thing as if we had typed number plus or equals number plus 2. What's going to happen is it's going to take our number and it's going to add 2 to it. It's basically like an increment operator, except that we're specifying what to add to it. So if we run this now, we should see that our number was 3, it added 2, so it'll be 5. And the same thing works for multiplication, division, subtraction. So now let's take a look at some of the relational operators. And what we can do here is, in Java, we can print out the value of a Boolean. So I'm going to create a Boolean called value, and we're going to set this to true. And then I'm going to print out the value of this Boolean. I'm going to print value. Let's see what we get here. We get the word true because it's true. So this allows us to test some equality operators. We can check to see if numbers are equal or not. We can do this right inside of our print line. So let's take a look at, if I do 3 is greater than 2. Is this true or false? It is true. We can do the same thing here. 3 is less than 2. That will be false. And then of course we could change this to greater than or equal to. And if we put a 3 here, then this is going to be true. Less than or equal to, we can see if 3 is equal to 3, which is true, or 3 is not equal to 3. And you can see that that is false. And this really isn't going to be very applicable to right now until we actually get into conditionals. But if you can imagine, we're going to get to a place where we're going to want to do something if some variable is greater than another one, or